Good day, students and viewers. You are welcome to the studios of Maths X. We are still on set theory. In our previous class, we were on set operations and we went into union and intersection of sets. And in that class also, we linked up our union and intersection of sets to a Venn diagram. In today's class, we will consolidate on what we had started earlier. We will go into more set operations that I would have you, my dear students and viewers, know, so that you will be grounded in your set operations. As you watch our video, we would be happy when you subscribe, like, and share our videos. Do not fail to do that. Happy viewing. Our next set operation is called disjoint of sets. For disjoint of sets, this refers to when two or more sets have no elements in common, which means they end up yielding an empty set. So when two or more sets have no element in common, those sets are said to be disjoint. So for disjoint, when two or more sets, pardon me for writing here, have no elements in common, the sets are said to be disjoint. For example, if I have a certain set D, let's use B first. Set B is 2, 4, 6, 8. I believe we've used that. Then I have a certain set D. Set D refers to A, B, C, and D. So B intersection D is an empty set. Or you can do this. So this is when two sets have, like I said, when two or more sets have no elements in common. So it's an intersection, but nothing is common to these two sets. So we have an empty set. So that is our disjoint. The next set operation I want us to talk about is called complement of sets. Symbol for complement of sets is, if that set is set A, you have A prime. Some books use A to like a superscript of C on top. Yes, so there's a like a 1 on top. It's called prime. So that is symbol for complement of a set. So that is it. Complement of a set refers to elements that are not in a particular subset, but they are in the universal or mother set. So I'll put it down. So complement of a set refers to elements that are not in a particular subset, maybe A, but are in the universal set mu. I'll take off that part of the board. Let's look at an example. I have a certain mother set which contains elements from 1, 2, 3, till 10. Then I have a certain set A which is 1, 2, 3, and 4. To express a complement, because I said that complement of a set, these are elements that are not in a particular subset A, but are in the universal set mu. So that is our mu. So a complement will be definitely 5, 6, 7, 8, 9, and of course 10 itself. So this is a complement. So this is a way of expressing elements that are not in a particular subset, but they are in a mother set. So if set A is 1, 2, 3, and 4, then complement of set A will be 5, 6, 7, 8, 9, and 10. That is for complement. There are other set operations I want us to still talk about. The fifth one is called the difference of sets. Symbol being like a minus sign, sometimes a slash is being used. So for difference of sets, it's not really very common. The fifth and the sixth one I'll talk about are not very commonly used. All right, but they are still there. They are still part of our set operations. So this is for difference of sets. For difference of set, that is a symbol. It looks like a minus sign, but it's not. Sometimes a slash is being used. All right, take note of that. So difference of two sets, A and B, are elements that are in set A, but they are not in set B. So if I have set A, what I used earlier was 1, 2, 3, and 4. And then I have my set B, which is 2, 4, 6, and 8. So my difference of A and B will be 1, and 3. So the elements that are in set A, which are not in set B, as you can see, 2 and 4 are in set B. So the ones that are in set A and that are not in set B will be is 1, 3. So this is the set. So the difference of set A and B in this case is 1, 3. The sixth set operation, my dear students and viewers, is the symmetric difference. Number 6 is the symmetric difference of sets. And its symbol is a triangle, or some books use a cross with a circle inside. So this is the symbol for symmetric difference. So symmetric difference of two sets A and B refers to elements that are in A or B but not in both of them. So there are elements that are in A or B but not in both. So let's put that down. So the symmetric difference of two sets A and B refers to elements that are in A or B but not in both of them. So let's try this. This is our elements A and B. What do we mean by this? So if we have A on B, which is symbol for symmetric difference, we had that here. So what elements are we talking about? So symmetric difference of two sets A and B refers to elements that are in A or B but not in both of them. So which elements are those? Now, if you look at these sets A and B, the elements in both of them are 2 and 4. 2 and 4, 2 and 4. But there are other elements that are in A or B, but not in both. So picking those elements out, I have a 1, I have a 3. There's 1 here, there's 3 here, but it's not here. Continuing, I have 6 and 8. So that is 6 and 8. It's as simple as that, my dear students and viewers. My dear students and viewers, this is it for set operations. We've given you all together 6 set operations to ensure that you are properly grounded when it comes to operations involving sets in mathematics. In our next class, we will still press on with set theory. In that class, we will talk about applications of Venn diagrams to solve set problems. We will also take detours in set builders, notations, and key set symbols in our next class. Till then, my dear students and viewers, do keep watching the videos of Maths X, like, share, and do not forget to subscribe to our videos. As you do so, God bless you. Thank you for your time.